So this is the last topic we need to talk about with exponents and logs. And we are going to talk about something called the natural log today. And what it looks like on your calculator is ln. And so I don't know why, but like think of n as natural and L as log. So it's for natural log. And if I pull up a calculator, you will see that probably next to the e to the x button, like on my little calculator here, I have a button that says ln on it, and then e to the x on top of it. And that's because natural log and log are inverses. I hope that when you are looking at your calculator, you will also see that there's a button that says log. We talked about this one. This is the base 10 log, and above it, it says 10 to the x. So it's a good hint to you that these are inverses because they share that button on the calculator. And so if you use Desmos, let's see if I can get a Desmos browser going. Desmos also will have something in functions, and if you go over to the miscellaneous functions, right here, ln. Okay, so ln is natural log. The definition of y equals ln x, or the natural log of x, is the inverse of e to the x. So natural log of x equals y if and only if e to the y equals x. And this was the definition of inverses from last semester, but also just knowing that e and natural log are inverses of each other is pretty important because we can use it to solve for lots of different things. So I have two examples here. It says solve for x. Well, I know that the base here is e, so it might help you to write that in, and then hopefully you remember, if you don't know what to do, you can swoop. So now I have e to the 2.5 equals x. So you can change natural log just like we did regular log. Okay, so when did log base b of 2 equals x, remember you did like b to the x equals 2, you did the swoopy thing. I can do the same swoopy thing here. And so then this is now a calculator problem. So e to the 2.5 equals x. So let me bring up my Desmos and go e, and that's in here. Remember, e is just a number, that 2.718. Once you type it in, Desmos already knows what you're talking about. E to the 2.5, I believe, right? This. Oopsies. Okay, so e to the 2.5, so your answer here is 12.182. Okay. Another pretty cool thing is natural log of e. So if I scroll back up here a little bit, I don't need to do that. Let's just talk about natural log of e real quick. This is like an aside before we do this one. This is base e. So if I did my swoopy thing here, then e to the x would equal e to the 1, which is really great. Natural log of e then equals 1. It's pretty amazing because here would be x equals 1. Okay, so that's what this tells us, x equals 1. So natural log of e is 1. Again, that so I have determined the time. Okay, determine the time. That means I don't know what t is. It would take for an investment yielding 4.5%. This is my rate, equals 0.045, compounded continuously. When you see this word, that means you're going to use that PERT equation. And I want to triple in value. So it's going to be 3 times as big as it was before. when we were talking about one of the homework problems that had oil and it was removing impurities and we didn't know where it started. And so if you were with me when we were talking about that, a couple of us, if you don't know where it starts, choose 1. So I'm going to choose my P to equal 1. Okay, I don't know how much money you put in, but I do know that if I triple P, I get 3. And that's my answer, right? Because it wants to triple in value. So that's why I'm going to pick 1. If you picked 100, then your triple would be 300. Okay, so I'm picking out all the pieces. I know continuously, so I know which equation I'm going to find. So I'm going to, let me erase this real quick. And I'm just going to write A equals 3, so I have a little more room. R equals 0.045. And I think those are all the pieces because we are looking for T. It says determine the time. So 3 equals 1, that's my P, E to the R, R is 0.045, and we don't know time. So the first thing I'm going to do is 1 times E is 1 times E, or it's just E. So I'm going to kind of get rid of that step, E to the 0.045 T. And we talked about this yesterday with a few of us as well, that like I can't take the T'th root. So I can't get rid of that exponent. What I can do is take the natural log of both sides. So as an algebra move, I'm going to take the natural log of both sides. So take ln as an algebra move. When I do that, I have natural log of 3 on this side and natural log of e to the 0.045 times t on this side. Since I'm using log or natural log, and they work a lot alike, I know I can bring this down front. In fact, they work exactly alike. So now I have 0.045 t, that was my exponent, times the natural log of e. I put this over here. What is natural log e? It's 1. And so what happens is this just goes away because it changes to 1. So I don't even need it anymore. And that's the really awesome part about using natural log when you're using the letter E. If you want to use regular log, you would get the same answer. It would just take 1 extra step, but no big deal. Log and natural log can be used interchangeably. So I'm just going to divide by this 0.045. So you've got, let's find our calculator, natural log of 3. I'm going to go functions, natural log of 3. I'll put an extra parenthesis, I think, divided by, and it was 0.045, I believe. Whoopsies. 24.4. So time equals 24.4, and that would be years, right? Because our time was in years. If we go back to the problem, it wants to know how many, determine the amount of time, T would be in years here. So 24.4 years, you would triple your value. If you put in $1, you'd get out 3. If you put in $1,000, you'd get out 3,000. So then I've got a couple more problems where we're going to use log or natural log to solve. And you may have seen these before. Hopefully it's not too surprising. But when you are stuck here with something like this and you need to use log or natural log to solve for exponents. Okay, so I'm going to use natural log. It doesn't matter if you use log base 10 or natural log base e. So my first step is going to be to take the natural log of both sides as an algebra move. So now I have natural log of 5 to the 4x equals natural log of 73. Now I can bring this down front. So I have 4x times natural log 5 equals natural log 73. You can do this in one step if you'd like. You could multiply or 2 steps. But now I'm just doing algebra, remembering that this ln stuff is all just numbers. So my calculator, I'm going to type, oops, I forgot the 4. Natural log 73 divided by 4 times natural log 5. So let's see if I can remember that. Natural log 73 divided by 4 times the natural log of 5, right? See, I forgot. Yes. All right. And what does it say to us? 0.66645. All right. So x equals 0.66645. And you could check your work by typing this in. 5 to this. So 5 to the 4 times point. Look at this. Isn't it? I'm getting closer and closer and closer to my answer of 73. So a way to check is to put your answer back in and just try it. So maybe you want to now pause the video. This one's going to take a little bit longer. It's a little bit more difficult, or see if you can get started. Okay, so first thing I'm going to do is take the natural log of both sides. So natural log of 6 to the x is natural log of 3 to the x plus 2 exponent. I'm going to bring the exponents down in both cases. So the first thing that I'm going to do, and this seems weird, but natural log 3 is a number, so I need to distribute it to both pieces. So I'm going to start by making mine a decimal. So I'm going to find natural log 3. I'm going to do it on my calculator next to me instead of Desmos. So now I have, this is x plus 2. 1.098 equals x times natural log of 6. Okay, so I'm going to distribute this now. This is really weird because I've got a ton of decimals here. I'm going to just keep this over here. 1.098x plus, what's 1.098 times 2? 2.1972. Okay. Ugh. I need to, I can, multiply this one out too. So that's what I'm going to do next. Natural log of 6. So now I have 1.79, should be a 1. 1.7917x equals 1.098x plus 2.1972. So now I've got a two-sided algebra equation, but it looks super weird because of these weird decimals. So I'm going to subtract this from both sides. So I'm going to subtract, and that was like natural log 3, right? So I'm just going to type that in my calculator. So now I have 0.69314x equals 2.1972. The last step is going to be to divide. I ran out of room. So I'm going to take 2 times the natural log of 3 divided by 0.69314. I got x equals 3.17. Yours may be a little different depending on what you rounded to, but of course you can always, if I type this in, 6 to the 3.18 power, I got 2.292. I'm just checking my work for you. 0.2, that was supposed to be a point. And then if I do the other one, 3 to the 5.17. 5.17. Hopefully I get something, yep, something close. 292.89. So because I rounded, they're a little bit off, but you can tell they are pretty close. They're just decimal points off. So that's kind of nice. All right, your homework will be posted.